It'd be great if you can grow realistic trees like this in the computer. I think it's great. However, this tree is not realistic enough already to be brought into nowadays animations. Because most people want more realistic animations today. Like, just how many of you would prefer more realistic trees than trees like this? A bit more than a few. Therefore, today I want to reinvent the tree. My name is Wilbert Osmond. I'm a 14-year-old junior high school student from Indonesia. At the moment, I'll be presenting an interesting story of mine about how my interest in sequences and figures of trees meet in computation. So, to be honest, I was really not satisfied by nowadays the realistic activity of nowadays animation. Even Frozen, the highest grossing animated film ever. I realized that the structures of trees in Frozen are not realistic enough. These L system trees are not as perfect as the trees in my surroundings. I think these nowadays animations need modifications again. So I've been talking about linear system, but I haven't explained about it. So linear system is a language it's a kind of language to model every growth in computation, especially growth in nature, like snowflakes, trees, and many more. And then I found a sequence around me, which is the Padovan sequence. I love sequence, and I like pattern too. So Padovan sequence is a generalization of Fibonacci sequence. Fibonacci sequence is a famous sequence that is closely related to natural geometry, like the Nautilus shell and more. These are the first few values of Padovan sequence. And this sequence is described by this recalculation. In 2 months of my learning in Padovan sequence, I found an alternative mathematical formula. The value of n term in Padovan sequence equals to the sum of the value from 0th term until the Padovan n minus 5, and added by a constant of 2, and n must be greater or equal to 5. This is the translation again. So I'm doing this research with the purpose that I want to innovate the conventional animation system in order to generate trees and plants in my surroundings much more naturally, and of course using the combination of linear system and Padovan sequence. So Richard Padovan, who is the founder of Padovan sequence, originally found his sequence by setting up a condition on the Fibonacci sequence. To be more precise, killing those rabbits. So suppose there is a case that in the end of 2013, you are given a mixed pair of newly born rabbits with these conditions. Rabbits reach maturity in 1 month, and after 1 month maturity, female rabbits give birth to another mixed pair of rabbits every month. Until they die, and only die in 3 months later. So the question is, how many pairs of rabbits will be there in the end of 2014? It took a long time, isn't it? But the solution is Padovan sequence. So the answer is 21 pairs of rabbits. So from the analogy of rabbit problem solution, I modified the biological application of Padovan sequence into the structures of trees and plants. A very good example of Padovan tree is Southern Mediterranean. This is what it looks like. So this is the recalculation. This recalculation at least needs at least first 3 variables. Suppose they are A, B, C with no constants, and it starts with A. The rules are A becomes B, B becomes C, C becomes A and B, so on and so forth. This is the string sequence. The values of the string sequence are the values of Padovan sequence. This is the end of the Southern Mediterranean. Here is the algorithm comparison between the conventional linear system and the Padovan linear system. It might look rather complicated. So both start with same first three steps, which is the start, draw a line, and move to the end of the line. In the conventional linear system, after the step of moving to the end of the line, the process goes two ways, which is rotate to left and right by 0 until 90 degrees based on mouse position. And after both two steps will draw a shorter line than the previous one. And after that, we will check whether the end of the line length have exceeded the limit or not. If it hasn't, the process will go back to move to the end of the line. And this process will keep looping until the end of the line has exceeded the limit. And when they do, the process finish. When the Padovan linear system, the process goes two ways, which is draw a shorter line than the previous one, the middle that does not move, and it will check whether the end iteration is an even or odd integer. If it's an odd integer, it will rotate to right as 0 until 90 degrees based on position. If it's an even integer, it will rotate to left and as 0 until 90 degrees based on position. After that, both steps will draw a shorter line than the previous one. And after that, it will check whether the end of the line has exceeded the limit or not. If it hasn't, then go back to the end of the line again until it's a yes. And when it's a yes, the process finished. Here's the result of my research. So this is conventional linear system, and this is the generated Southern made happen on Padovan tree. So to calculate whether this tree is a Padovan tree or not, we make arcs intersecting those lines. So 1 point, 1 point, 1 point, 2 points, 3 points, 4 points, 5 points. And this is the sequence. The sequence stops here because the end. I set a limit in the end of the line length, as I said in the algorithm. So this is a tree in front of my friend's house. So through algorithms and computation, my interest in sequence and figures of trees have given interesting results in generating the trees in my surroundings. This is a generated tree. They look similar, isn't it? This is a back view of my brother's school, and this is a generated tree. These are the trees near my security post in my complex. This shows that even the neglected plants, like this biological weathering, can also be generated by Padovan linear system. This is a branch of the plants, to be precise. So there are various generated trees from Padovan linear system that I haven't found the simulations in my surroundings yet by changing the parameters in the coding. Gorgeous, isn't it? Some of them might not really exist in real life, but in animations, animators can make like tree monster or plant monster or whatever. So by mathematical sequences, like Padovan sequence, can be combined with the L system in order to innovate the conventional linear system in growing some trees and plants in my surroundings much more naturally. This may lead to more interesting and further advancement in computing the visualization of the complex nature, like snowflakes. This could also contribute to recent trend of computation for animations as celebrity in many applications, be it movies, pictures, games, or many more. So, do you know what the coolest part is? This is just started. I've still many roads ahead. So first, I should try other sequences rather than just trying Padovan sequence. And I should expand the simulations from my surroundings into more general places. I should add more features too in the program, like making the leaves, flowers, or whatever, and many more. So what if nowadays animations, like the Frozen, are being enhanced by Padovan linear system? We can make more realistic animations each day as people's demand on the realisticity of the animations keep fluctuating high each day. I think you will agree that I've reinvented the tree. I hope I've been able to explain all aspects in my research, but if there's any questions left, I'm very willing to answer. Thank you.
Padovan sequence is a generalization of a Fibonacci sequence. I don't think we can use the word generalization at the beginning. Yeah, so Padovan sequence is a generalization of a Fibonacci sequence. I'm not sure if you can use generalization as the word. Because Fibonacci sequence is the current term that is the sum of the last two terms, right? But Padovan sequence is the current term is the sum of the second and the third last terms. So it's not really a generalization.
In literature, they say this is the in Wikipedia they say that Padovan sequence is the generalization of Fibonacci sequence. And Padovan, Padovan, who is the founder, set up one more condition of in the Fibonacci sequence analogy, which is the rabbit problem solution. And in the rabbit problem solution, these first two conditions are the conditions in Fibonacci's rabbit, while in Padovan sequence he set one more condition by clearing them. So this is a generalization.
Would you call it generalization?
Yeah, because
That's a point.
Yeah, I don't think. Yeah. Well, it's just something that you probably have to check further, in my opinion, because you have to be careful with the terminology. Generalization in maths is like it has to be valid for every thing. In which case, this one is not, because it has a conditional, one more condition. So it doesn't mean that it's a generalization. It's just something that you have to make sure. Because Wikipedia is not really a fixed reference.
It's not. If it's not a generalization, we have to know.
You should probably just say it's similar to Fibonacci sequence.
The structure.
Yeah.
Okay. We'll chat about that.
Yeah. And if you go to the slides where you have A, B, C, and then you Is it a Padovan sequence?
Yeah.
Well, I thought you said C should be the sum of the second and the third digits, so it should start from
A and minus A.
yes. Yes. So what is A? A is the first.
It's the first
the
variable.
first term.
Yeah.
B is the second term.
Yeah.
C is the third term. So by definition, D is the sum of A and B, right? So it's not C. You don't start from C. You start summing from D, from the fourth term. Because
No. We can start, but just by the third term.
no, but this one is Fibonacci sequence. This one is Padovan sequence.
No, this is Padovan. If Fibonacci, they are just variables A, B, A, B. Is your question? Sorry. Yeah.
Yeah, I'm not sure if it's clear because it depends on how you define ABC basically. So if A is the first term, B is the second term, C is third term. So if you so you have 1, 1, 1, right? And they are ordered. 1, 1. First one is 1, second one is 1, third one is 1. Now Padovan is the fourth one. The fourth one is the sum of the first two, right?
The fourth term is the sum of the second and the first and the second term.
Yes. How about the third one?
The zeroth term, which the value is 0, and the first term, which is 1.
Yes, exactly. So what is C here?
The third term.
But why is it? Oh, I see. Okay, sorry. Okay, I thought C. Okay, D. A, B, C, D. Yes.
Next question.
You said before it could be used for the biological application. This what you make. Yes, it could be biological application for tree and plants.
Yeah.
This program for this simulation.
Yeah.
I'm not sure because if you connect if you make the related the biological to the mathematical computer simulation.
This sequence has
Just for the simulation.
Padovan tree, and
Okay.
like the short-term may happen, it is a Padovan tree, so it's biological. Then in this research, I'm modeling that tree.
You just modeling the tree,
Growing tree.
growing tree
Yeah.
with your simulations, not for the aspect of the biological. No.
But this I think interesting. So if you can also simulate it also for the biological
Biological.
application.
What do you mean by?
For example, for the optimization of the fertilizer for the trees. So that is.
But I'm afraid that it won't be computer science.
Yeah, in the computer science,
that's-
but
Yeah, not a problem for the computer simulation, but you can use this. Maybe can be useful for the conservation. You can give to the like the national park to simulate to present this simulation of the tree and plant with the Fibonacci like LC system. What you are doing now. So this is very interesting because biologists can be calculated how many years this can be to grow up of these plants or tree. So you can make the calculation with your simulation. This is an interesting aspect.
That's cool.
I have one idea probably. Is it possible to use this technique to model the spread of disease? Like if one gets infected and then next 2 person will be infected and then
Yeah.
baru ditantangin kemarin.
And environmental condition. This is very important. We would think that environmental condition.
And how did you change the parameters so that you can get different types of trees? What did you change?
In the coding,
But this aspect.
How many processing?
Bisa tulisan nggak?
I have the coding in my computer, and I
Boleh. Oh, pakai papan tulis.
original one, the probability is minus H, and the Padovan system is H over 1 by 2, H over G. Is the branch. That recursive. H recursive. The length of the branch. Because if you just use H, it might not be Padovan. So we want to
How can you get the different type of tree?
change the parameters.
The H one?
Yeah, H per like this is 1.2 or something. H per 1.5.
Question from the audience. After you heard his voice, you're sure it's definitely junior high. Any question? Jeffrey? Yeah, I did.
You mentioned a little more.
Yeah.
Maybe you can have an explain.
Theoretically, randomized system is a parallel grading system.
Sorry?
It is theoretically it is a parallel grading system and a type of formal grammar which consists of initial, so like initial, start, and the rules of production.
Okay.
So the three strings in the initial axiom will expand.
Okay.
Yeah, I did.
You are using quite a specific example as reinventing the trees. Do you think there is any more broader applications for this algorithm?
I'm sorry.
Do you think there is any broader application for this algorithm? Ada aplikasi yang lebih luas untuk ini daripada hanya reinventing the tree.
Tadi Pak, yang barusan.
Ya, jadi ini khususnya ya. Jadi adik-adik ini ada contoh suatu riset yang base-nya hanya komputer. Tapi sebenarnya aplikasinya sangat luas sekali. Kalau ide-ide tadi bisa menjadi atau kerjasama. Jadi artinya kalau memang nggak kuat di simulasi, itu bisa juga eksperimen. Tapi dengan dukungan simulasi ini bisa memperkuat hasil eksperimen yang dilakukan. Jadi ini hal yang sangat menarik dalam rangka untuk membuat ide-ide itu bisa muncul dari kalian semua. Jadi ini contohnya banyak sekali tadi di aplikasi di tanaman itu simulasinya banyak sekali, bisa untuk mengoptimalkan pupuk, terus mengoptimalkan hama untuk menanggulangi hama, tadi kaitannya dengan penyakit dan seterusnya banyak sekali. Dan ini mungkin contoh yang bisa dijadikan memori adik-adik semuanya. Ya, terima kasih.
Okay, we still have 4 presentation left.